one presenter. I'm going to do the same thing we did last time, if that seems to work, where I'm going to put on the forum, question call for presentations and start organizing the next session. Today, after Benji's done, we can choose to either continue the discussion of his presentation, or if you guys have any topics in mind, like you have an hour to think about what you would like the rest of the people to discuss. Everybody getting notifications from the forum?
I think so.
No?
Yes.
Yeah, okay, if you're not, you need to go subscribe again, because when NI migrated to the new web version, you kept all your subscriptions, and it looks like you're still subscribed, but you're not getting the email notifications. You have to actually resubscribe for those. So if you have any trouble figuring that out, let me know, and I can help you set it up. All right, so Benji presented at NI Week about DCAF, and then he was at the unit testing presentation that I think Sam did, and at the unit testing panel. And then we were talking about, continuous integration and how cool using unit testing is. And Benji said, I have the perfect case study. I was like, oh, do you want to present about it at LabVIEW Architects Forum? So he said yes. I'm really excited about this presentation. As you know, I don't like unit testing at all. So this is close to my heart. If you are sick and tired of seeing unit testing presentations, then submit your presentation so we have other presentations to talk about. Otherwise, I'll keep choosing them. All right? Okay, Benji, all yours.
Well, to start with unit testing, before I get into DCAF and how we're testing, is do you need unit testing? And the answer is yes. Everyone needs unit testing, and for us in DCAF, it has been great success. It's basically one of the things we require in order to be successful with all the development and all the goals we have and all the challenges we have. In general, regardless of if it's a small project or a large project, testing is important. Unit testing is a way of testing, and you should not wait for production. Now, what I'm going to cover here, I think everyone here has seen or heard about DCAF. Everyone knows what DCAF is? Okay, I see some no, so I will talk a little bit of what DCAF is so I can show you then why it's important for us. That will be just a couple of minutes. Then I will talk to you about what's the developer cycle that we have in DCAF, how people collaborate with us, how we're developing everything. And once we have that, we will go into how we're doing the unit testing in DCAF. What are the challenges we're getting? And I will show you specific examples of unit tests we have in DCAF and how they're helping us and basically how everything is working for us. So the first part is DCAF is a distributed control and automation framework. This is pretty much our big marketing slide. DCAF is an open source LabVIEW framework that has configuration-based editing. It works with latest values, so it's basically tag values. It contains a data engine that works as an abstraction layer and basically processes all the information, runs into different inputs and between different outputs and inputs, and does everything for us. The main importance of what it gives us to us is, one, it's a scalable architecture that can be extended. So you can use DCAF as your main architecture. You can use DCAF next to whatever you have, or you can just see what we're doing in DCAF and implement it to your application. It is based on plugins. It's one of the main intentions with us is that all the plugins can be reused. So the plugins don't care if they're running inside of the engine. They don't care if there's other plugins running. They just talk to the engine, and that's it. They don't care about what's happening around them. DCAF is basically designed on single point tag values, and that's what we provide directly from the framework. There's ways to work around these with messages and waveforms, but that's not provided by the framework itself. And one of the things we had is when we build this, we try people to do things right. We limit you on some things that you can do them if you try really hard, but we try to guide you through the right programming practices, including using unit testing and other things. So all our templates includes examples of unit testing. Also, it includes already configuration and timing, and it's optimized for real time. So anywhere, DCAF is completely built on LabVIEW, so anywhere you can run LabVIEW, you can run DCAF. Now, itself, what it has is just basically a big engine that it has modules have inputs that receive information from the outside, pass information to the engine. Then we have process that gets information from the engine, makes something to it, for example, scaling or alarming, puts the information back into the engine, and then we have the output and puts it out. That's basically how a DCAF application works. As I said, this is not a DCAF application, so I'm not going to get into all the details of what DCAF is. The main thing is I want to show what things we include with DCAF. When you download DCAF, we include templates, we include examples, We have the configuration side, that is the compression editor. There's modules by themselves. Then we have the runtime part, that is the modules also actually executing. So we have options to configure the module. We have options to run the module. And that makes more sense when I show you how DCAF works. Is my... What? Okay. So the main idea with DCAF is we have the compression editor. This is basically where we can modify or configure our system. You can just come here, add extra modules. So add a target. So for example, if I want something to run in the compact Rio, then inside of the compact Rio, it specifies what the thing is running. For me, it's an engine. I can add multiple engines. You should not add more engines that you have cores on the target. So if you have a dual core, you should only have 2 engines. If you have a quad core, you can have 4 engines, because each one of them is running at the same priority. So if you want to keep them deterministic, you just have to do that. Once you have an engine, for example, if I'm trying to do a simple data acquisition, you could just come, add a local I/O. We could add DACMX. Then I could, once I have DACMX, I can just add the channels that I have. So it will check just with a normal DAC. I can select the module. I could say, well, I'm reading thermocouple, select OK. That is basically just reading my system. Then if I want to log this or show it in a UI, I could just add here a local UI. I could select here in my UI to configure the UI. So I have one simple UI that is called UI. Configure UI will import all the controls that I have automatically. And I have here the indicator and the target waveform chart. The advantage here is I can just map from one to the other. So in here I can select which tag I'm writing. That is the waveform chart. I can save this configuration, and then on my host, I just need to specify which configuration I have. That in this case would be, well, I already have one saved. I click run. And based on whatever I configure is how it's going to be running. So for example, with this 500 configuration, it's just reading the simulated DAC card and show it in on a graph. So I have here my UI. So it's just doing that. The nice thing with this is I can just stop this. I can change the configuration for one that I have more complex, that is an actual control system. I can click run. And without changing anything in the LabVIEW code, just by changing the configuration, I can have a completely different program running. So once it starts running, I can open this view, and basically, this is the temperature controller example that we show in every LabVIEW class for real time. And I didn't have to change anything. So the main thing how this works is I have modules. Each module has code. So for example, for this UI, there's no code. The configuration for this is, instead of having just the PID, I could show you. This is the configuration that I'm actually running. Now, if I want to see in the mappings what is actually happening, I can see I have a temperature control model, I have a temperature control controller, and then I have storing everything to PID and sending everything to the front panel. That's basically what is configured and what I'm doing in this project. Now, as I said, the intention of this is not show you DCAF and all the things that you can do. It's just, okay, this is DCAF, we have a lot of things to do, and we have a lot of modules, we have a lot of plugins, and we have a lot of people collaborating with DCAF. Now, how does this work? Well, as I said, DCAF is open source. So if you go to LabVIEW DCAF on GitHub, you will find every repository we have, including templates, including modules, including documentation. And we have a lot of people collaborating with us, adding new things. So one of the first things that we needed to figure out what we have. We have thousands of BIs. Actually, right now, I think we have more than 50 BI package managers with all the extra modules. 2,000 BIs. We have support components that are not included in DCAF. So in DCAF, we're using other things like CES, that is the compression editor framework. That's what we're using for our compression. And DCAF is pulling all these parts. And as I said, seeing all this complexity, what we have, a large code base, we have multiple developers, we have multiple independent releases. So one of the things with DCAF is we don't have 1 or 2 annual releases a year. We keep releasing new modules for bug fixes every couple of weeks, every couple of months, so depending when it happens. And we don't have the luxury to wait for all the tests to take, so we need everything to run fast and make sure that what we have works. And also we have external collaborators, so it's not like, well, when Matt is doing something, I know what he's doing next to me and I can make sure he's running the code. If someone that is not there submits code, I have to make sure that the code is going to run and that it will collaborate with everything. So it goes a little bit of how our developers work. So whenever someone wants to collaborate with DCAF, the first thing they have to do is they have to create an issue. So in general, we can go to any package. We have issues here. You can select any issue that you want, and basically, once you have an issue selected, you assign it to yourself, then you're going to create a branch. Then while you're working on your branch, you can make as many commits as you want to your branch, and eventually it comes to the part that you are going to make a pull request. In the pull request is the moment we see what you're submitting, and for us, a pull request, in order to be integrated into the main branch, requires several things. One is that all the UTF passes, all our unit tests need to pass. There has to be a review by someone, and basically, it has to be able to build. So we have a Jenkins server that does everything for us. Runs the unit test and builds. And then just have to be a human checking, hey, all these passes, make a comparison, and accept the pull request. So, for example, one of our pull requests, what?
From the poll, the last one?
Yes.
Let's try to get context of all this.
Yeah, the pull request is this part. So the thing is, sometimes after the pull request, there might be some collaboration. And the thing is, when you're making the pull request, that doesn't mean it's already merged with the code. Once we click accept, then it gets into the code, and basically it closes the issue. So, for example, one of our pull requests, how it would look, I have here pull requests that are closed. We're basically using the same icons they have in here in GitHub. But basically it shows us what BIs changed, and that's the review that someone has to do. So we have all the BIs that change. We can see what it, well, it disappears once you accept it, but it will not allow you to merge the change unless unit test passes and unless it was built successfully.
And review.
What? And review. So those three things need to be done. Yes? No, they're, yes. There's a, well, not LabVIEW compare, there's a special tool for doing that. We have it on the repo. But basically it allows you to take images between both of the BIs using the compare and basically create the images.
How much of it's being enforced by the tool versus human?
So unit test is completely enforced by the tool. Unit test is enforced, building is enforced by that. Technically, there's ways to override, but normally we will not approve anything unless it passes all the automatic tools.
When does that happen?
What?
When does the automatic tool running happen?
It runs the moment you click pull request. So once you make a pull request, what it will trigger is our Jenkins build. So basically, what it will do is automatically, Jenkins detects there's a change in the GitHub repo. It creates a checkout, builds everything, gets the temporary director, runs the unit test framework. So for example, in here you can see in this build that failed, it didn't pass unit test. Then after that, it tries to build the build package manager. If that passes, it installs it on the machine and then tells us all the checks pass. You are okay to merge it. Now, that's why, for us, it becomes really important to have the unit test, because doing this manually every time we want to do pull request becomes much a hassle. People won't do it because, oh, I forgot to run unit test this pull request, and maybe we included a new extra bug. Now, I'm mentioning this because there's a lot of debates on what exactly is a unit test. We can go to the point of what is a unit, and there's a lot of things that we could discuss. I'm pretty sure we could have a full summit just discussing these kind of things. In general, the definition I really like with unit test is testing something in isolation. I'm testing whatever is my unit by itself. It could be just a VI, or it can be a module, or in our case, it could be a top-level VI that is calling several VIs. But the main thing is you can run it without the rest of the system. There's also integration testing. So we do have other processes that basically have a big integration testing running different modules together. That is an independent package, and that runs once a day. And the main thing is system test is you actually have the final system and you're trying to run it. Now, for us with DCAF, one of the biggest things is what is regression testing. Because we need to know that whoever is committing something is still working. Whatever we had before that worked is still going to work, and you didn't break anything new. So we include all these together because Jenkins is running all our tests, and we're using unit tests for regression testing. Doing regression testing without unit tests becomes really hard. Once you find something doesn't work, it's hard to find what is not working. So these tools work together, and one of the things is, as I said, in order to use unit tests, you need to be able to use it easy. I think there was a really good example of somebody presented, I think here, or I don't remember where, that they were saying like, unit testing is like flossing. A lot of people don't do it because it's hard or it breaks your flow. And in order to do it properly, you need to have the right tools. So regardless of what you're doing, having unit tests, a framework that runs for unit tests is useful. There's multiple of them. There's Karaya, there's JKI VI unit tester, and there's the LabVIEW unit tester. Each one of them has its advantages or disadvantages. In our case, the main reason we're using LabVIEW unit test, the one we include with LabVIEW, is because, one, as NI, we want to be able to use our product so we can give more feedback internally. And the other, it runs on real-time targets. So some of our tests are running directly with a compact video connected to our server, and we want to be able to run that. And this makes it easier for us. Now, when we're including all our templates, and you're creating, for example, a new LabVIEW module, it already includes templates for you. So in the template when you create it, it already creates a folder that contains all the unit tests, and also it contains a folder for the LabVIEW unit test framework configurations. We have them separated for two reasons. One is not everyone is using the LabVIEW tools, so you can still keep the VIs and then just modify them for your actual unit test framework. And the other is if you put them, these configurations, unit test configurations inside of a library, when you build a VI package, it will fail. So you have to put them outside.
What if your unit test gets saved in the same location as the VI, or are they saved in separate locations?
We have a separate folder for all our unit tests, and then we have the normal code. So basically, you could remove them.
Yeah, that's my suggestion to my customers too, because if you want to, when you're doing a package build or CL or whatever, it's a lot easier to say, include this entire folder.
Yes.
Than having to go manually and
And that's how we were doing. And actually, for all our older packages, we were removing the unit test. So if you see the older versions of the modules library, for example, the modules module, it will not contain the unit test. Some of the newer modules, we're actually including the unit test now, because we want them to be examples for people creating their own unit tests. But again, that's because DCAF is a framework for people to develop. It's not a finished project. If you actually have a finished project, most of the time you don't want the unit test to ship. And that's why we have them in independent components. And actually in the disk is a different folder. Any questions so far? Well, now that I talk a little bit of what is the things we have in DCAF, why are we doing unit testing, and how it's being useful, I will go into a couple of unit tests that I find really interesting and has been a big difference for us. So who of here has had problems with cross-linking? Okay, so
If you haven't raised your hand, are you sure you're programming it?
one of the biggest problems with cross-linking is, especially when you're working on multiple targets, is if you open a class in the compact region and a class on LabVIEW, if it's open in both in the same project, they lock. So one of the ways we're getting around that is all our modules are split into 3 classes. We have a configuration class that basically it's a really simple class that contains the data, all the common components, to string and from string methods, so we can actually save it to disk, and that's it. Then we have an editor node that is a class that has a UI to modify that configuration class, and then we actually have a runtime that runs based on the configuration from the configuration class. So by having 3 different classes, we prevent that if the editor node is running on Windows and the runtime is running on real time, they will not lock the library. And also it allows us to have independent things. So if you have, for example, in your editor node, you're calling Excel, you don't want that code to be dragged into the real-time part. So by having these 3 classes split, it allows us to have a lot of flexibility. The problem is, it's really easy that I have a type there that I decide to put it on the editor node, but then I require it on the runtime. What happens with that is now the runtime has a dependency to the editor node, and we don't want that in DCAF. In DCAF, the editor node can have dependencies to the configuration and actually contains a configuration object inside of it, and the runtime contains a configuration object inside of it. But we cannot have the dependency going the other way around. Now, to prevent that, what we're doing is a really easy trick. If you have something that you want to find, if it's cross-linked to another library, is you can create a new project, add the class into that project, and then search in dependencies if the things you want are there. So, for example, we have a simple, we created a project that basically creates programmatically a new LabVIEW project. It adds the configuration class, and then it checks in dependencies if we have the other 2 classes. And that's a really simple test, but...
Yes, it's curious. We have that, but on the analyzer test, and I've never occurred to me that it would go into unit testing, but it's all over unit testing.
As Matt was saying, we have, this one is a really important for us, but because we have cross-linking a lot. Because it's a really easy mistake to make. Oh, I have this enum here, I want to use it on the other place. For us, if there's something like that, most of the time we will just, oh, we need the enum in both sides, pass it to the configuration class, and the configuration class will contain it.
Yeah, but it's just one of the things that never occurred to me. There are already analyzer tests that we use in unit testing. These ones that never occurred to me, but it makes sense because unit testing tends to be executed more than the analyzer test.
Well, but I see what you what's that about, because it's a philosophical distinction.
It's a code style.
That's static text.
That's a code style.
Yeah, which would be something the analysts do, whereas we think of unit testing as an exercise. Unit testing is about code that's running. That's about inspecting the code artifacts themselves.
But it goes back to the definition of unit. If your unit is your library, then one of the tests for that library is whether it has cross-link.
Well, and yeah, right. And just going back to the whole, we make it
Yeah.
And that's a useful distinction for our organization, how we organize our projects. But for their projects, it made more sense to break that barrier.
Because you don't have people running the analyzer.
Well, we don't do that. It's one of the things we have not enabled, but our pipeline in Jenkins now supports running the analyzer. So we just need to enable it, but we have been working on other stuff, so we have not enabled it yet. But basically the main idea is, well, we have some pipes that are already doing it, but the moment before you actually have to accept, when it's a pull request, one of the extra checks is if it passes the analyzer. As I said, other groups that are using our same pipeline are already using it, but we were letting them test it, and then we're going to pull it.
Yeah, that's right.
Well, and that gets into, I think, more problems is that, Jenkins will, automatically fail and not let you merge. And I feel like that's a lot more debate over what is a failed VI analyzer test. It's like, oh, is this really meaning you, can't pull in your package?
That's why you have to pare down the...
That's why you use the CSV for the analyzer.
Yeah.
Because the config...
But there's a lot more debate over to what is a failed VI analyzer check than what is a failed unit test.
Yeah,
if unit test fails,
I certainly don't want to fail my merge because I didn't have the full
yeah. You don't comment on it.
But for example, for us, it's a big deal, cross-linking stuff, Because it's, when you're cross-linking to other modules, it will break execution. Because, for example, sometimes cross-linking, if you're cross-linking to an editor class that contains things that will not run on the real-time part, it might break everything.
Yeah.
So it might actually not run.
Turning that into the unit test stream is going to be a much more informative failure.
Yes.
Yeah. Oh, this module won't load. Huh? Error 1003.
Yes.
Not that that's ever happened to you. Not that that's ever happened to you.
No, today. No, it could happen.
But one day.
No, it hasn't happened in the last 3 hours.
Have you been programming?
No. I took my daughter to ballet.
So another really simple unit test, and I think it's one of the best examples we have for unit tests. As I said, our compression class has the serialization and deserialization. That is what we normally save to a file. That's how we can restore the compression that you save on disk and then pull it on the runtime. Now, as I said, with unit tests, you want to be able to run it outside. So we don't need to run the compression inside of the engine or the editor or anything else. So for doing this, basically, I have just the methods from here basically I'm creating the object, I'm configuring it and initializing it, and then I serialize, deserialize, and compare the results of both things. Now, something that is interesting, actually this slide is older because now we have actually a pass value. With the unit test in LabVIEW, it allows you to manage cases. And you can set, hey, run these different things and pass or not pass. For us, we're moving everything into the VI because a lot of people will not have the compression we're using. So we want for them to be able to use the VI itself. So you can just run this VI, you will get all the LEDs saying it passed or it didn't. And then you can integrate it with the rest of your systems. Now, in order to, here it is. So for example, when I'm creating a unit test in the unit test framework, you are able to say, hey, these are my inputs, these are my outputs, and you can configure cases. We're not using anything of this. We're just using there's a pass boolean. Did it pass? Yes. Then the system passed. We are also taking advantage that it tells us code coverage. But that's pretty much what we're getting from it. That we can call it from our continuous integration system, that it passes or not, and that it gives us coverage. And it runs on real time. That's what we get out of this frame.
So your test case sequences have one CI call that's like
pretty much.
Yeah. The reporting, though.
Yes, the reporting is pretty good. So
it does actually report.
Yes. And one of the things is, in order to do unit testing, sometimes you need to create a stump VI, something that is going to configure the rest of the system. So for us, as I said, we're going to be testing modules without having the engine, without having any configuration. So we have to create that programmatically. So any module that you download in the template, we have create test configuration. For example, in here, I'm just checking, hey, this module, which channel type support, then create a channel for every data type, and then I create the names and other stuff that I need for test outside of the module to know what the module is configured as. So if I go back to here, this configuration is telling me which lines are available. And then I can check that the lines available are the same lines that I'm getting from my application. Now, we have a module for system link, and for example, this is the unit test to make sure it runs. Now, again, we're testing it by itself without the rest of the engine, so you can make sure the module is working by itself. Now, I'm mentioning this one because in order for this unit test to run, you actually have to have a system link server connected to the system. So sometimes you need hardware or you need extra stuff to work for the system. And I would say one of the biggest issues we have sometimes when we're running tests is we forget the drivers. So if you're testing the CAN module and the test machine doesn't have the CAN driver, it will fail. So, which also tells you, make sure when you're deploying the system, you need to have this too. So the unit test here has an extra help of things that you have to double check. So in here, what I have is the same VI that I said before. So I'm configuring everything for unit testing. Then I'm basically starting my system and I just check if the input passed, the output passed. And inside of this VI, what I have is I just write everything to system link. So system link is a server. I can write everything to there. Then my module is supposed to read from there. And then I check that whatever I read is the same thing that I write. And that's what my unit test is doing. Now, I'm showing this because sometimes the runtime test for our modules, you do it manually. You click run and see what's going on. But the thing is, you can also automate them. If you know what is supposed to happen, you can just work with the outside of your module, then execute the module itself and compare that the values were true. And this basically can run. Another one that is basically what we were saying of multiple cases, we need to exercise all the possible values for our module to see if it passes or not. Is, for example, in the modules, well, in all the modules, there's a validate line that checks that our configuration is valid. That you're not doing a read and a write from the same value, for example, or you're not, in the case of modules, have anyone here used modules? So the thing is, in modules, you have registers, and for example, you have 4008, 4005, so you don't want to override registers. So there's tests to make that. So normally, you would, in unit tests, add a case with all the potential things that you will modify, like if the input, make this the input, make this other the input. In our case, as we are not using that feature, what it does is add some complexity to our BIs, and this is what you have. You get all the possibilities, so we run the compression check with one compression, with a second compression, with a third compression, and then we check everything in. As you said, is our test and sequence has a single BI, and we have all the different cases for that single BI. And that's, the main thing here is we're using a framework. And the idea with this is that if you're not using unit test framework, but you're using Karaya, you can just see, oh, this is the things that they need. You add the asserts in the specific places because you know what we're doing.
You're in the realm of not wanting to dictate the full stack.
Exactly. But we're trying to get people to use unit testing because that's the extent of it. You should be using it. Now, how you use it, we cannot really say that, but the main thing is you should be doing the unit testing.
Yeah. I'm finally on a budget for it. Awesome.
There's also a nice side effect that compressing into fewer unit tests in unit test framework makes it run faster,
yes,
which is nice. So
I would say the biggest drawback with unit test framework is that it's really slow loading everything. Especially, for example, when you're working with real-time targets, every single BI that runs will load everything to the target, then basically restart it again, load everything, and do it every single time. So you have to do all the download. So if you have 20 different cases, it will take a lot more. If you have everything in a single one that just passes or fails, it gives you the idea. Now, sometimes, besides having just the pass, we add extra LEDs that says, failed on this specific thing. So in the report, it says, hey, this is what fails.
On this one, I didn't do a compound arithmetic and did a build array just so you could probe that wire to figure out what test failed more easily, because I didn't want to add all the booleans.
And there's a right-click plugin for compound arithmetic, so it'll probe every wire going into it.
We use 2014.
Well, that's not my fault.
When we use 2015, that would be very helpful.
Yes. Well, actually, we're going to start moving DCAF to 2015 soon, but as we were still on 2014, most of our tools were developed with 2014.
Yeah, that's one of those plugins I use like once every 2 or 3 months. When I see the compound arithmetic and it's got 16 booleans going into it, I'm like, oh yeah, I can right-click on that.
Well, and for example, this is a template of how you will get it. When you create your test, it doesn't tell you what you're doing. It's basically just saying, hey, if this module is this type, you should put code here. If this module is of the other type, then this is the part that you're going to modify. This is because we don't know exactly what your module is doing. We're just giving you guidance of what unit tests that you need to do.
That looks like it, even when, then, but not quite.
Yes.
Yes, good.
What?
There's a school of thought on unit testing that in order to make it easier to write your unit tests, you write them in the form of even, X, when, Y, then, expectancy is. And James McNally had an article, if you guys want, I can post it on the forum post about this. And he actually has a package that you can download from GitHub that adds templates to your palette, so you can drag and just put the exceed and then when with your using the template. So anyway, if you are having issues with unit tests, that's a good way to know
And now, one of the main questions that happens with unit tests is what should I be unit testing? The main thing is, in order to start unit tests, you need to have requirements. You need to know what you are going to test in order to be able to create tests. The second thing that is really important when you're doing this is that you need to realize you're never going to end testing. You can test things and keep adding tests forever, and that could be bad because you're not going to finish your project, so you need to choose which tests you're going to be adding. So there's another problem. If you think I created all my tests and I'm done, then it will limit you. One of the biggest things we have in DCAF is what happens when a bug happens. I think everyone has seen this part. Didn't we fix this last week? Why is it happening again? And unit test is one of the best things that exists to prevent this from happening. What you should do is, okay, a bug happened. So actually, before fixing the bug, you should create a unit test that tests the BI and say, hey, this is failing. Once you do that, then you create basically, you fix the error and then click your unit test and say, hey, it's passed. The reason I'm saying is you should create a unit test before actually fixing it is because two things. If you do it this way, one, you have to verify what is the expected behavior you want. So that helps you basically fix the thing better. This is failing because of this thing, so I need to check it. Also, sometimes you might fix parts of the problem, then you create a unit test that says, oh, it should pass right now, but didn't catch all the errors or all the problems. Exactly. But when it was broken, you create the unit test, then you will know it should not pass. And then basically you run your test and include it on your unit test suite.
So you were saying earlier that unit test you need to have the requirements. I find it also that the requirements are like a uniform, right?
Yes.
I've heard that they exist, but I've never really seen them. So what we do is like try to ask more questions. And sometimes if you have kind of a fuzzy feature, just asking how would I test it and start implementing the test gets you to understanding what it is that you're supposed to implement in the first place. So, and you become the first user of your area.
Then the main question you have to avoid, the main answer you have to avoid is, what should we test? Test everything. Everything should be tested.
Yeah, final secondary experience. I've been finding that I do this, and I have a concept, but it isn't actually defined until we've defined the tests that establish that we completed this feature.
Yes.
So, you know, like I try to believe I think they're terrible ideas. But I believe this, and I think when you're writing your test, you're specking out your feature, and when you're done, your unit tests are your requirement documents.
So I would argue with that. The thing is, there's different levels of requirements. Sometimes if you go to the aerospace level in which requirements have to specify everything to a dot and there's no change and everything like that, requirements become a burden and it becomes a problem.
And I've worked in this environment.
Exactly.
And I can tell you that what the administrators and the project managers tell you is going to happen and what actually happens when you build this stuff, they have a passive relationship in the hall.
Yes. So, and that's the thing. Requirements to that level are not really useful. But requirements can be as simple as I can have a paper napkin that says what are we expecting to have.
I believe in writing down features.
And that's the thing. Requirements are an agreement between you and the one that is giving you the one that is asking you to write the code in what your code should be doing.
Yeah.
And that's what a requirement is. If you don't have that, then you can write the best code that doesn't work for what the customer
wants. Agreement. I have worked in enough spaces where requirements has that rigid definition, and most people that you talk to about requirements who not write software believe that, or even they're very vague statements. And so I often push against those. No, we're talking about features. We're talking about user stories. You sit down with software, what do you expect to happen? These are all great conversations to have, but they don't turn into, I believe the system shall X, Y, Z when ABC happens. And that's the pushback. That's the thing that doesn't get defined until you write the test.
Well, it depends on what customer you have, because sometimes if you don't even try to do that, like we worked with an oil and gas customer one time. They only had some use cases, but they didn't want to tell us what they expected the hardware to do. So is like, yeah, this has to happen like this. And we will say, okay, so you're saying it has to do this and this. No, we're not saying that. Okay, then how can I test it? I need to know what you're supposed to do here. And that's the part of what I'm saying. If you don't know what the behavior is, and you're not defining it as requirement, even if it's not a requirement document, but a list of features that you have to have, you cannot test it.
Right. Well, like I said, I think we're in final agreement.
Yes.
I think it's more of a chicken and an egg thing. I don't think you have this, you know, so you actually write the software test.
Yep.
Well, you got to actually nail it down. Anything else is,
Well, and then also the thing is you can go with, there's different approaches. There's some people that build the unit test after they finish the code. There's people that build the unit test before you write the code. That is what is unit testing, test-driven design. You first write the test, and you test the code that is going to work. I would say the advantage of going with that is when you're doing test-driven design is the project manager is budgeting time for testing. When you don't do that, sometimes they don't budget any time for testing, which is important. Regardless of you're doing at the beginning or at the end, you need time for testing.
That's moving to derail you.
Yes, it's okay.
We got some.
Yes, I mean, we do have the starting time.
Yeah, but you might get tired of standing up there, so
I have been class. I technically could speak about DCAF for the next 2 days and not have any problem. I do have the slides. But yeah. So basically the conclusions or things I wanted to mention is, one, you cannot test everything. Because testing everything requires a lot of time, requires a lot of investment, and if you're using unit tests in LabVIEW, it will take hours to test everything. So you have to choose what you're going to test. Test for bugs, test for features that you need to cover that are basic for the system to work, and that's what I was saying. Sometimes with the requirements, you can go to those specific things that you have to cover. Now, again, I insist that you cannot do the proper testing without having the requirements because you can test that something is working, but that might not be what the customer is asking.
Probably arguable.
Yes.
As opposed to whether they
Yes. Norm?
Different but related.
Yeah.
When it comes down to testing, when you do unit tests, the thing that I've seen other people do is they build up unit test calluses, effectively. They build up faith in the fact that everything's fine because they're running their unit tests and it's always doing the exact same thing, exact same order. They're like, it's great, it's great, it's great. And the minute that I get my fingers in the system and I start monkeying around, everything falls to crap.
Yes.
And so it's not to say that it validates that's by any stretch. However, what's been done, what have y'all done in the process of randomization and, hey, doing things in different orders to try to force out those other types of error?
Oh, like rats do.
Exactly. You put the cat on the keyboard, right? Other than that, is there anything in particular that y'all have done to test those scenarios or the more randomization?
So we don't really do that many randomization tests in the sense that most of the things we want to do is deterministic. So we're expecting the compression to be fixed. Like right now, most of our tests are trying to do specific features, specific functions that have to work exactly the same way. If it's not working the same way, for example, right now we found a memory leak. So once we figure what's causing this memory leak, we will add a unit test that tests that memory leak is not happening.
Yeah, so on the randomization thing, the example that I had is sometimes you know, for example, you're doing analytical passwords or some combination of characters, and there's no way you're going to be testing all possible combinations. Doing random tests is okay as long as you are storing as part of your result what was the input that you used.
Now, I'm not talking about input to an individual unit. I'm talking about the order in which you run your test. We've got a test suite that we've got running on one of our systems that we're doing right now. And everybody's happy because they hit the test. Everything turns green on the other side. They're all happy. The minute that I run this test, and then I run that test, and I do something else in between, run that.
So their unit tests are state dependent from the previous.
Exactly.
It can, yes, exactly. And
that's a no-no.
I would say what we're doing against that is all our unit tests. Basically, that's one of the main things with unit tests. Your unit test has to be independent from the rest of them.
But isn't that in that very specific case, you're not actually testing when they would be dependent. when somebody's using your system, they're not
Yes.
starting up and shutting it down in between every
Oh, but
individual action.
you then do unit tests as units of step, like testing a macro. Like, for example, if you're testing a media player, and I don't know why I know about that, if you're testing a media player, it's very different to do loading a playlist and loading a video, and then doing the play, and then what happens if your customer, or your end user gets click happy.
Trigger happy, yeah.
So those things can be tested. So you test that the play by itself works, and then you have another unit test that says, I'm going to now test the click happy situation.
So what I'm trying to get at is there clearly it's not, yes, you can make yet another thing that very specifically tests it in that very specific order.
Yeah.
But what I'm trying to get at, and have you heard of even, because it sounds like you haven't done it at this point,
No,
but the idea of like, allow the system to do things at different times.
So what's
and
happening?
make sure it never goes through.
So I would.
When you're finding out those situations where running unit tests in different order is causing a failure, then those guys should be now, your unit becomes a larger thing
Yes.
that has the same tendency. And then now you can do, what did you call it, Darren? The not a sequence, kind of like not a sequence thing?
Oh, yeah, the stack sequence, but not really,
Yeah.
where you do a while loop with the case structure inside, wire for the iteration. Yeah.
So basically what you do is you call your unit test in the sequence that you know is failing now. And now your job is to make it pass. So normally you don't want to have a unit test that is so humongous that you're not going to be supporting it. But if you're calling unit tests that are full already by your system and already maintained as an individual test, you can totally programmatically run them. And in both unit test framework, DCAF tester has an option of loading unit test from files and running them. You could tell them in which order to run them. You could programmatically say, I'm going to be doing this.
Now, you raise an interesting thing about that, and this is just theoretically, is because if you introduce a random element order, if your sequences are long enough, then your test results are essentially,
Yes.
and that's going to change your analysis of whether or not you're close.
Right, that's the idea.
I'm not sure how we would do that analysis unless you started breaking out the old.
Well, that's the thing. Just randomizing inputs or basically doing anything random in unit test, you still have to keep some things, and you can say, I have one random test, but you cannot depend on that because the same thing you're saying, I might hit the right thing. There's a higher chance that you're not going to hit what you need to do. And you have to be careful with that. And the thing is, when that's happening, most of the problem is that one unit test is dependent on the other. And I have seen that not only in unit testing. We had a hardware tester for a customer, and when we were running our test and sequence, if step A run before step B, it worked fine. If it was run the other way, it will fail. In that case, it was basically because step A was powering a capacitor in the dot, so the next test will be able to pass. Now, in here, when you're talking with software, the thing is you have a better control of what's the state of your software. So technically, if you're worried about those kind of things, you can reset your application. And it goes a little bit on how the state of things work. So for what?
You would change then the setup for that unit.
Exactly, and that comes in encapsulation. So, for example, if your application is heavily dependent on functional global variables, then you have to be careful and you need to make sure that when you're starting your application, the functional global variable is restarted. If you're using classes, then it's really easy because what I'm testing is an instance of a class. And that instance of a class should behave the same way regardless of test A or test B because I'm testing different instances.
I'm testing actors, and the actors start to stop.
I'm thinking more like hardware. So we're dealing with preliminary hardware. It sounds like the scenario that I'm talking about. Y'all don't run into enough data and you're like, yes, of course, yes, we do that. We've seen this in this first.
Yes, and I would say the problem with hardware is it's harder to control the state between one test to the other. So changing the flow of the test will affect how the hardware behaves. But that's rather than having it in a random way, as Fabiola was saying. What you should do is, okay, we're testing this hardware twice. Test A, B, and C, and then C, B, A, and you have to do a specific sequence. Because if you're just going random, the first piece goes and it's ABC, and it's fast. But the next one probably would fail, but now as you change the test, now it also passes. So randomizing undermines the capacity of your tester or your unit test to actually catch a failure. Rather than encasing it, it increases the probability of it giving you or false positives or false negatives.
But it kind of circles back to can't test everything. And I wonder for large enough application, what does that arrangement grant say? I wonder what that looks like. I just wonder what that looks like.
Well, but it is what we were saying, right? At the minute that we find out that running the unit test in different order fails, that is calling for you need a new unit test that is going to now be running those things in that order.
But maybe you just accept that a subset of the functionality is going to be tested in there. Like, you might say, okay, well, I don't want to test everything. And in this case, I might just accept because I'm lazy, actually. The fact that I have to do these in this order. And maybe that's okay based on the prior. Maybe it does need to be actually fleshed out better so that you have more stable unit tests that require that.
But the issue here is if you play the unit test in a different order because if everything that goes to add a new feature, then these becomes a new unit test. That's what I'm saying. Like now we need, if it is needed to be running in order, then we need to have a new unit test that runs.
Well, I guess what I'm thinking, you're thinking about unit tests to make sure something I got fixed stays stable. I'm thinking about unit tests from the standpoint of trying to ferret out actually things that may have gone wrong or maybe didn't even exist. Because if I'm talking about, I'm going to change power levels and frequencies and my EVM should always reside underneath a certain level, then I can make sure that as I move across, I'm not always sweeping frequency in a positive manner and power level in a negative manner. And
You're
then
trying to
I let
find bugs. You're trying to automatically find bugs.
Yeah.
Well, yeah, I mean, that's the thing. The system should be stable, it should be good across all these. But if I, move here, there, and it's a matter of how many different permutations do I go versus allowing, and that's what I was kind of fishing for, was have you all had a thing where, like, yes, we have an M cross N cross P / table, and we allow it to kind of do its thing, and it's,
No, and that also with Fabiola is saying of the integration testing. So the thing is, you don't have to test with the same intensity every single time. So, for example, for us, every time you make a pull request, I don't need to run all the integration tests. I need to test the local thing. We have a larger test that can do a lot of extra things that runs once a day when everyone is awake. It doesn't bother the hardware and allows you to be working. And in that one, you can have, instead of just testing the same order, you could have additional orders. And you can have additional things. Yes?
So one temptation when you get into unit testing is wanting to test every possible permutation and getting to all the different corner cases. And that's a recipe for you not being happy with unit testing.
Yes.
Because you want to focus on the high priority features, and as you start discovering the corner cases that you didn't cover, then you start beefing up the unit tests that need beefing up. Does that make sense? If you try to do every permutation and create this random table that is going to be generating all possible combinations, it goes back to trying to test everything. But if you have a candidate that you know is one where it is possible that you're not covering all the cases, then yes, design that unit test to do some random input. So maybe you catch that case that you haven't applied. But if you do that, as you know, I know it. Make sure you do record what the input combinations were, because the first time that I did something like that, we didn't, and we were never ever able to reproduce what was that corner case that made it fail. And that's when I was like, oh, the report should actually report what was the input.
Yes. Well, as I said, I literally have a lot of slides. So I do have this in a slide. One of the tips for creating a unit test is tests should be self-contained and should not be affected by each other. The thing is, if you see that behavior of, if I run test A after test B, then that means they're dependent. As I said, in the hardware one, we find it because we were able to disable tests. So at some point, the contract manufacturer wanted to speed things up. So he disabled one of the tests. But what happened is, if test A was not running, B will fail, because the unit was not in the right position. So when you're unit testing, you want to prevent that. And as I said, you could have, when you're doing the big level of testing, add additional tests that, as Fabiola is saying, your unit becomes, rather than one test, it's a couple of tests together. And you can do permutations and other stuff. But rather than just doing it completely random, you should decide what orders you want to to make sure you're always testing the ones that you think are a problem.
And when you find a bug, because you didn't test that corner, then you add that corner safety.
Yes.
When when I said here that we were designing hardware, we always had a phase during our hardware design where we would stress test the product. It wasn't something we did regularly like you do unit tests, but at some point there was always value in doing like a multi-day stress test that exercises everything, lots of different ways. But that's not something every day.
I think the biggest difference I'm seeing is that we're talking about, I think, more of a characterization or even production test kind of scenario where you have a set of steps that very often end up being dependent on each other from the perspective of test design. And you're not so much doing like software or code unit testing and down below kind of operation.
Well, I'm thinking system. At the heart of it, we've got a system right now, and I would say that the dev team is very interested in running unit tests not only on the software, but to make sure that we're getting consistent parametric results for what we're doing. And to make sure that, like, oh yeah, the R&D gave us a new millimeter wave head, so therefore it's going to get the same result out of it. And so we're using this test framework that we've got, and we need running stuff. And it's not just testing the code, it's running testing the code, but it's making sure that we're getting the same results out of the hardware that we're also running through as well. And so, yes, there's two things technically going on here. And the challenge ends up being is how hard does somebody have to get lucky in terms of stumbling on the problem, or would the sheer randomization of what should be unit and self-contained tests, just doing it in random order, be sufficient? Would the framework itself effectively allow us to ferret out whether or not does the actual order even matter? Theoretically, it shouldn't, right? And so if we haven't done that test, I can almost guarantee that if there was a feature of what was there that we were running through allowed for something like that, we would have found more bugs at that point in time. To which then we could have ferreted out why it happened, created the explicit unit test, and then allowed that to
So depending on the framework, you can use unit test framework allows you to programmatically decide order.
Right.
You can totally do that.
Right, that sounded like about the closest. But it still sounded like that's not something that y'all have, or anybody else in the room, does to ensure that you actually are operating in a true...
I think you have it on one of your slides where a good unit test is repeatable, and it needs to be constrained, and it needs to run the same way every time, and you need to know what your variables are. What you are doing is...
But that's what my system has right now. It's repeatable, gets the same results every time, everything seems to be self-contained, but if you never...
But what you're asking for is no longer unit testing. You're doing integration testing, and what I'm saying is...
I gotcha.
Yes.
There we go.
And you can do it. You can totally use...
I'm sorry.
You can totally use existing test frameworks to do system integration. This is do system testing, totally, and integration testing. You can totally do it. A lot of people do it. And you can do the opposite too. People use test to do unit testing.
Yes.
Because it's a sequence, and it has pass fails. So it goes both ways. It just really comes down to what is it that you're trying to do. So we're talking about unit testing is more about a healthy, quality assurance cycle going for your software. Well, what you're doing is more what he was saying about doing integration testing or stress testing. Something that you have to do, but you might not be doing it every day.
And I think part of your question is how do I determine the quality of my test? Your tests are not technically unit tests if they behave differently.
If they're dependent on the... Yeah, I guess that's another aspect.
So your question is more along the lines of how do I determine the quality of my test?
Well, it's not only the test, but sometimes the hardware is part of the system aspect of it. So my tests might be just fine, but the hardware underneath, that I have no control over that software as well. And so that's where it kind of falls a little bit more into the system. It doesn't fall into the test standards category, I wouldn't necessarily say. We're still trying to, and it runs fast. It runs in, 40 seconds, the entire suite of tests that we've got right now. But we do have multiple pieces of the system in it, and it's not just the software that's running. And so that's where I think my desires and what I'm looking at from falls possibly on the outskirts of, there's an overlap, clearly, but there's other aspects to it, and that's kind of why I'm curious if you all have done that too, because of, hey, the hardware also is, or the bigger system is playing into this category, where indeed I'm trying to figure out state dependence of the system. Maybe the software's fine, but the hardware.
This reminds me a lot of some of of the things we hear about in the software world with like bug testing, especially for like security holes and things where they'll take a given piece of code that has some input, and the vector of possible inputs for that are potentially infinite, right? There might be some string or some very large operation. And what you actually do is you can look at what types of inputs in the past have caused code to crash or cause leaks or cause injection attacks. And you can make sort of hypothesis that, well, maybe these types of characters or these types of configurations could cause it. And you actually have kind of a neural network kind of, or some sort of fuzzy input thing that will kind of take those basic starting points, edit them around until it actually finds a point where that code model does fail and on it. So in the wider set of computer science, there's actually like that type of stuff that happens. And you probably could reuse some of those ideas in this scenario if you were able to take, well, what are your actual variables? Where do you think they might have some issues, and where can you actually plug in different vectors?
Yeah, like if we happen to change game state, settling time increases, so it gets bad results.
Exactly.
But it is more, at that point, it's more characterization and configuration. It's really not checking that code, like, always, always.
Right. That's what you add to the statistical.
Yeah. Right.
You're making a statistical thing about your code instead of
And then the best unit test happens after you've made the observation of I need to test these exact things to make sure it's good. And you're kind of in a regime of, I think I'm testing that, but I'm not quite sure yet. What additional cases do I need to test?
Well, they call it cases.
Using unit tests to help ensure the right
The test
coverage.
framework that you guys are using, is that a custom test framework, or is it an existing?
No, it's called Fitness. It's not a LabVIEW based one. It's called Fitness. It's Java based over the web. It's actually kind of slick, but long story short, it's kind of we're executing through it. I can show it. All of us are look at that.
Yeah, I guess the thing we can look at, you can programmatically look at the test.
Yeah, it's all, technically speaking, it's all bio web based.
So you should be able to.
So it's all those things.
Well, an important thing is also having tests doesn't guarantee there will not be bugs. A lot of people think, hey, this is tested, it will not have bugs.
Yeah, or not, the favorite one is like, I don't know why it's saying that there's bugs, the unit test, huh? And nobody knows that looks to see if the unit test was well written.
Yes.
I'll see how I know that.
And there can be bugs in the unit test.
Yes, that's what I'm saying. That's how I know that one.
Unit test for your unit test.
Yeah, when the first,
All the way down.
I think the first year, or probably the first 6 months I used unit testing, I was so confident in how well it was going. Now we got to one feature where I was like, but the unit test passes. And I was like adamant that everyone else was wrong. The unit test was wrong.
Yeah. Well, I had one that, as I was saying, I'm making a Boolean changing to a pass because when it's not cross-linked, it will fail that it's not cross-linked, but the pass has to be the other way around. If I don't put the note, I will pass the unit test, but that means it was cross-linked.
The other thing about that is make sure that all your unit tests by default report failures.
Yes.
The default custom unit test from unit test framework, or if you do a custom unit test, comes with hassle. That's the worst thing you can do, because you might have named that unit test with the right name, but the default is something. So you might get a whole set of security that your test has. Every time
A lot of
you're
red clouds there.
Yes. Also, one of the things we do is when we're running our so we are getting all the unit test results passed as an XML file, so we can actually read them from the cloud and everything.
That gets posted to, does it get posted to GitHub?
No, it just gets posted internally right now.
Because everybody who contributes has that unit test framework on the computer.
They will.
Technically, no.
Technically, you could just do it without unit test framework, submit your code, and then we will fail the code if it
They can't add unit tests, or they can add unit tests.
They couldn't add or change unit tests. But our build server would run it, so you could change the current.
Yes.
I guess theoretically they could write the LV test as a text file.
Yes.
No. Let's not do that here.
No, theoretically. That's why I said, theoretically, they could do it. They could take one and keep an LV test and then just modify the input test.
It'd be less expensive to
developer suite, most customers already have unit tests. It's basically included with anything we sell now, so unless you go with LabVIEW full development or LabVIEW base, almost everything else will have it. What? Professional or any.
But theoretically,
Yes.
now, as long as we're talking about numeric, Boolean, like the minute you start with constants and wait for numeric and all that, then yes. But if we're talking about simple things, you could potentially theoretically do it in an LD test without using test.
So you try.
For that? So I have tried, yeah.
Well, and the thing is for us, the test, so basically you could run the LabVIEW test and it will see the pass or fail. You don't need to run it from the unit test part. So still you could verify that your code is working.
And create another issue to create the unit.
Yes. So someone else can create it for you.
Yeah, the other issue that can happen when you manually create the LD test file is that each version of unit test framework interprets arrays as a different parameters.
So Fabiola, you have already manually created unit test files?
Yeah, that's my experience here.
It just breaks all the time.
Well, the reason is when you upgrade your code from one version of LabVIEW to a newer version of LabVIEW, and then you start using the new unit test framework, every version of LabVIEW has changed. You can go check it. Has changed how they interpret the array. So what we had was a really old project that had unit tests that were created in different versions. So we had to manually go and inspect the ones that were not loading correctly, why it wasn't that they were not loading correctly. Yeah, if you go to the unit testing group, I think they're supposed to when I did that exercise. No, it's brackets versus curly brackets versus, yeah.
Well, and the other two things that are really important is don't test in production. Yes, those 4 a.m. calls of when something is failing on the production line are awesome.
But before that,
And one extremely important that sometimes is not ours but of project managers is make time for testing. Testing time has to be accountable. And the thing is, time that you spend testing is time you're not going to be debugging. And when you're debugging and you have unit tests, you can run the unit test and that sometimes points you to the right failure.
and this is the one that is really hard to convince managers because they're like, I haven't seen any working code. What do you mean you're still working on tests? I need working code. And they don't realize that investing the time on doing this is going to reduce the headache later.
Yes. Tom?
When it comes down to getting started, you're introducing us what you're doing in DCAF.
Yes.
And already flying kind of scenario. Not starting from scratch, but say you were starting from some code that was already going. Do you have, Fab or anybody else, have an example of, here's some of the actually things, some of my notes, some of the ways that I actually figured out how to figure out actually what to do, because this thing really wasn't just like a bunch of little modules, and I could test each one separately. It was kind of a lot of things. And I think that's my biggest, it's like, you know, if I'm not working on something little and it's a little bit bigger, and like, what do? I mean, yes, I would start to make a list of 8,000 things, and I'm like, that's not going to do good. So I'm not even going to start on that, so I'd like to see an example.
So you're refactoring, right?
Not necessarily.
But you said that it's when you start touching things that things start to break.
You're a new owner.
No, I'm talking about like I'm building on just, it's not a refactor. Here where it is, I'm just.
But you're adding features to it.
Yeah.
It's two different stories. I mean, Ben, do you have an answer before I jump in?
Well, what I would say is, in there is sometimes, if you know the requirements of what the code is supposed to do, you can make tests of, A, if I'm receiving input A, I'm supposed to give input B of this function. You can make tests for that. The other thing is you can also check the bug list and what bugs have been fixed and create unit tests based on the bugs.
I'm not sure I'd even go that far with it, because I would just start with unit tests for what I
For the new features. So I would start for new features too. If you are going to go into existing code and want to retrofit, so if I am refactoring code, typical case, the PhD person knows enough LabVIEW to be dangerous, created a whole algorithm that works, but it's not performance. But I know that if I give it this input, I want this output, and that's what they're going to ask me, right, when I refactor. Then the very first thing I do is create a unit test for that. Then go and do all the refactoring, and then I can show the PhD that my way of doing the code provides exactly the same result that he has before, right? Now, if you are doing, this is another typical one, people want to get FDA approval or whatever, they have not been doing unit tests and they've gone along, and now they hire you to go and replicate the unit test. The biggest hurdle there is people getting very protective of their code. And they say, well, but I'm hiring you just to put the unit test. I don't want you to touch the code. How many here know about PCB design on board? So what happens if I tell a hardware designer that I need a test code? That's one of the features that they're asking me. You have to do a rep of the board. Would they understand that you have to do a rep of the board? Yes, because you are asking me to test the thing. So it's the same thing on software. When you're having to do a rep of how you created your software to make it more testable. How do you make it more testable? Instead of having like huge clusters going into a sub-VI, you look for only having the unit, the input that I need, and you do a lot of bundles and bundles into your code. So there are tricks and tips like that you have to do. But the very first thing to do is to understand that it is okay to modify things. And then you test them. And if it's working, you don't touch it. Right? But if they're asking you to come because you need to either prove that it is really working because they need some sort of regulatory approval, then they have to be open to being qualified. There's just no way around that. Does that help? Norm? No?
The other option is there's some alliance members, there's some alliance partners that can help you create unit tests for your application, so you can hire alliance members that can help you give you consulting. There's a lot of them in these rooms that can help you with that.
Randy, where's your bank account?
So I think it is also interesting if you're talking about like a UI feature, primarily UI feature where you're adding functionality. It might have a lot of back-end things, but that's part of the unit test occasionally. Right?
I'm trying, the impetus is somebody at the onset of the project that I was on. We're doing unit tests, we're doing good software programming. The minute I started getting into it, I'm like, I stopped, thought, and then said, forget it, because I couldn't wrap my mind around what the good first steps were for what I was explicitly doing with trying to add the feature set into what I was doing, because it didn't fit into, oh, I'm adding a function. That function was the bigger thing. There was and I can't verbalize this.
Well, that's another problem.
While I'm sitting here in consternation mode, I feel like I'm not alone in there's something, whatever it was,
yes.
It was my hesitation. I figured that's probably the other thing.
Yeah, no, they definitely is. And I think that I'm training too. One of the things that I change my wording when I'm training people in testing is you're not testing code, you're testing features.
Yeah.
Really good LabVIEW developers are going to be like, oh, I really do not need to write a unit test for that. Of course I know how to open a file and separate it and carve the columns out. I'm not going to spend the time. You're slowing me down. Why would I do a unit test? So yes, you're completely right. LabVIEW, if you know how to create a function that reads the text file and separate it in columns and everything, you can do it with your eyes closed. But implementing the feature of reading a comma-separated value that's provided by the end user that already has this column, this number, etc., that's a feature. And that needs to be tested to make sure that you are appropriate. So if you start thinking about what am I about to implement the feature and how would I test that feature, and it is totally fine if the test is going to be manual. First figure out how would you test it manually. And then once you have that, you're the one that told me that good engineer is a lazy engineer. Then you try to figure out how to automate it so you don't have to figure out how to do it. Does that make sense? Does that help?
It does. I'm still. It's not that I disagree with you.
It loops back to what I was harping on earlier about the departments versus unit I want to be able to do this. I'll sit down at my system and I want to be able to pull down this menu, select this selection, and I want to have this thing bar about to the side because it has some relevance to my job. You can articulate that. Then the question becomes, how do I know I did it? And from how do I know I did it comes the test parameters, which are the mirror image requirements. So think about that. I mean, my suggestion. What feature am I adding?
Perhaps the thing that would help individuals help the service be real.
You have no second presentation.
So what would help people? What would help people? Not tell them.
He's the devil. The angel says,
told me
keep
to-
talking. Keep talking.
No, if you want examples, there are examples that they testing groups.
It's the first steps. And I think perhaps something that would have, if I had one of y'all next to me in that process, maybe the thing that would have led me towards actually making something at all would be like, just make one.
Yeah.
Make individual, that's all I want you to do.
But that is, there are examples already.
Start.
And the first one you make, or the 10th one that you make, and you complete it. Because people learn.
Yeah. I think that's the
Remember the other day, I was telling you about how much trouble I was having with the code for the scales on.
Oh, yeah.
I wrote you that. So the first time I wrote that project.
So, when we're going to have a whole test suite, they're actually kind of terrible tests, except that they actually work. Now I write repeating tests. Which first one?
The
Writing test, man.
The second you go to write a feature, is when you say, wait,
How would I?
I can't write this yet because I have to make a test. Like, that's the entry point I would say.
Right, and that's what they want us to do, and I'm just like, I don't even know what this thing's supposed to look like.
You
at the end
know,
of the day. What the heck
and
am I gonna?
I
Then
can
you need to
hire
have
a
a conversation.
consultant, you know that.
I was the one. The conversation would have been with me. That's the thing. Or the conversation of what it should look like is like its internal like.
Hallway testing. Grab somebody else's project. I'm going to write this feature. What the hell is it supposed to look like? I'm not sure.
I will say one thing. The whole, write the test first.
Yeah.
Sometimes I don't think that way. Sometimes I work on the feature first and then I write the test. And some people might say that's bad. I say that's better than that.
Yeah, that's better than nothing, yeah.
Because if you're lacking the requirements or the clarity of implementation details, to even start the test, and you have to get your hands in the code and get it working at all, maybe you have to write the test. Sometimes it is easier to write the code to be tested than it is to write the test.
Well,
I suggest starting with the code to be tested and
Now, the other example, have you ever been doing this where you write a code, write a BI, and then you look at it and you're like, and you start plugging values on the input, and then hitting the run button and trying to see the output look right, and then you're like, I'm kind of convinced, and then you plug in other numbers, and then you run again and look at the output. You ever done that?
Yeah.
Yeah, well,
That's the point where
that's
that's kind of like the
in that moment, if nothing else, just go document what were the values that convinced you that it was right. Use it as a documentation tool at the beginning. Don't use it to test your code. Just use it to document. This is what convinced me that this was what this implemented correctly. If you are having that urge to test with different values, that's already telling you that you are not 100% confident.
most of my stuff ends up being not different values, it's order of operation. It's constantly order of operation.
to write a unit test that does this.
Yeah.
Right, that ends up being.
It's like scripting.
Well, guys, that's when.
No, I will just what Darren is saying. Sometimes it's better to do first the feature and then test, especially when the feature is not well defined. So when you're prototyping or doing other things, if you do the test first, you don't know what you're testing, so you cannot write it. And the thing is, writing tests has some overhead. So if you have to go through that overhead several times, it will be a waste of time.
Yeah.
That's the case.
Well, it depends, right? I have right now a feature that has 9 unit tests for a single thing, and it was because we were implementing every single corner case.
Yes.
So we would write a unit test for the first corner case, then make it pass, then write a unit test for the second corner case, and then make it pass to make sure that the first corner case was not breaking.
But in that case, the thing is, you already know the features and you're keeping the unit test. when the unit test is basically, I'm testing for this, oh, no, that's not what we need to test, and you have to create a new test, that's when you're wasting time. First, you define what you want to do, and that goes to the point I'm saying requirements. If you don't know what you're doing, you don't know what you're testing. If you don't know what your picture is supposed to be, like if I don't know that I have to get the CSV file into my system and read it in this way, then I cannot test it because I don't know what I have to do, and you have to define that first.
And at the end of the day, this entire process, whether test-driven development, write the test after, you don't write tests at all, you lay all this stuff out, and that's all of it, you know, you're going to write some tests that are going to knock you out, and you're going to throw them away. Okay?
Well, why not just keep them at that point?
I'll find a way.
They're not great paths, but sure.
Well, that's the thing, right? You always have to do something, but you
Yeah,
do something you don't care about.
Well, let me finish.
Yeah, so it's all iterative, and, you know, and one of the cool things I'm finding about the test-driven development is by the time I've written the test, I've half-written the feature. Because I've had to lay out the entire API for how to access that feature.
And that's the thing, it's like, I feel wrong presenting this. Yeah.
Yep.
No, thank you so much. It was, I'm glad that actually we could next time we might go to representative now, I don't know. You guys let me know if that's what you want to do.
Or we can experiment with like a presenter and open mic.
Yeah, like, well, these ones, obviously there's enough people that have something to say, that we have an opinion.
Four ideas in my head that I probably can't turn into 45 minutes. But I can come up and demonstrate something in 15.
So we have another half an hour. We can continue the discussion, or we can just break and, you know, some people can continue to cross Norm's brain. I used to tell him when he did TLB crimes, like I was at TLB, I used to tell him I need someone to give me a tour of your brain, but I want to guarantee that there's a road that's giving me a exit out.